Hello and welcome back. This video we're going to talk about several examples of solving some equations and the steps needed to get variables by themselves. So in this first one we are solving for y. Notice what's happening to y. We're adding 5, we're dividing by 2, so we're going to be undoing those things to both sides. I want to be minus 5 here, minus 5 here. So 2y will equal 28. And then notice to undo this 2, in order to, it's 2 times y, the opposite of that is dividing by 2. So I need to divide both sides. Notice I do it to both sides of the equation to keep it balanced. And then our answer is y equals 14. Remember, you can always check by substituting the number back in for the variable. And as you can see, 2 times 14, 28. And if you add 28 to 5, you will get 33. So that does check out. All right, let's look at another example here. Let me write it so we can see this is a rational equation, one that is written with a fraction involved. Several things happening to r. We're minus 3, we're times 4, and we're dividing by 3. First thing I'm going to do is multiply both sides by 3. And what that does is eliminates the 3 in the denominator, leaving us just with 4r minus 3. 7 times 3 on the right, 21. I'm going to add 3 to both sides. 21 plus 3 is 24. And then notice I have 4r left equal to 24. I'm going to divide both sides by 4. And we end up with r equal to 6. 24 divided by 4 is 6. Remember, you can always substitute this back in to check to make sure it works. Let's look at another one here. Solving for x. This time we have a distributive property to do. This 6 will need to be distributed to the x and the 1 to get 6x plus 6. Still have minus 2x, and we're equal to 54. So, first thing we need to do is combine like terms. I got this 6 and this negative 2, 6x negative 2x to make 4x. 4x plus 6 is equal to 54. Next I'm going to minus 6 from both sides. 4x equals 48. And then finally I'll divide by 4. 48 divided by 4 is 12, and that is what our variable, our unknown value, is equal to. Another one here. This time we're solving for b. We have variables on both sides. We're going to first move the 4b to the other side. 4b minus 4b here, minus 4b here. And then here we go. 7b minus 4b is 3b. And then we divide by 3 on both sides. b is equal to 27 divided by 3, 9. b is equal to 9. So that's variables on both sides. Another one with variable on both sides. Let's write this as 2c minus 4 all over 5 is equal to c plus 4. Alright, I'm going to get rid of this 5 first by multiplying both sides by it. Now, on the right side of the equation, I'll have to do the distributive property. Here the 5's cancel, leaving me with 2c minus 4. Then I need to distribute the 5 to the c and the 4 to get 5c plus 20. Trying to get c by itself, I'm going to take away 2c from both sides. That'll move the c's to the right side of the equation. And in the same step, I'm going to take away 20 from both sides. And this going through, these cancel out. Negative 4, negative 20 make negative 24. 5c minus 2c, 3c. And then, of course, the 20s cancel because positive and negative 20 cancel out. Final step, divide by 3. c is equal to negative 8. Right, let's look at another example here. This time we have a lot of parentheses, a lot of distributive properties. First thing, the 4 gets distributed up here, giving me 28z minus 12. I have a -6. On the right side I have a 6. Now I'm distributing 4, but think of it as -4, -4. -4 times 3z, -12z. -4 times -7, +28. And then we're going to put some terms together. -12, -6, -18. +6, +28. Should be a 34. Still have 28z on the left. We have -12z on the right. Alright, I'm going to move all the z's to the left. The way I'm going to do that is adding 12z to both sides. Adding 12z to both sides. And then I'm going to add 18 and add 18. Alright, 28 and 12 make 40. So we have 40z. And then the 34 and 18 make 52. Notice the 18s cancel, the 12z's cancel. Final step, I need to divide both sides by 40. We'll get a decimal here, I believe. 52 divides by 40 one time. You can see on the calculator, z will then equal 1.3. 1.3. Alright, now for some story problems. It says a rectangle has a length of 3.6, perimeter of 16.8 meters. What is the width of the rectangle in decimal form? Alright, let's get a little visual here. So we do have length of 3.6. Length on one side, length on the other. Don't know the width, so let's use a W for width. But I do know if I add everything up, all the sides, that gives me the perimeter. And it apparently equals 16.8. 3.6 gives us a 7.2. How many W's do we have? We have 2 of them. 2W. First thing I'm going to do is take away the 7.2 from both sides. And we end up with 9.6. And then we're going to divide by 2. Apparently the width is 4.8 meters. You can always check that. If we go back and do 3.6, 3.6, 4.8, 4.8, it will add up to 16.8. Alright, another story problem coming at you. $3.90 worth of nickels and quarters in a piggy bank. There are 6 more quarters than nickels. How many of each coin are in the piggy bank? Alright, well, let's start off with this equation. 3.9 equals the sum of nickels and quarters. Now, nickels, 10 cents. 5 cents. We know that. Nickel is worth 5 cents. 0.05 N. And quarters worth 25 cents, 0.25 Q. Now, you can't solve a single equation with 2 different variables. It does say there are 6 more quarters than nickels. The number of quarters is 6 more than nickels. Q is equal to 6 plus N. So I see this expression 6 plus N. I can substitute that in for the Q. 0.25 6 plus N in parentheses. Still have the 0.05 N. And equal to 3.9. Alright, I'm going to distribute the 0.25. 0.25 times 6 is 1.5. And I have the 0.25 N. Still have 0.05 N, haven't messed with that yet. Still have 3.9. You can also write it 3.90, it doesn't matter. 0.05, 0.25 gives us 0.3n. Still have 1.5 here. 3.9 on the left. I'm going to take away 1.5. Alright, 3.9 minus 1.5, 2.4. Then we'll divide by 0.3. 2.4 divided by 0.3, n is equal to 8. That tells us 8 nickels. 8 nickels. And then to find the quarters, all we need to do is take 6 plus 8, since I now know the n. Number of quarters is 14. 14 quarters, 8 nickels. Alright, and finally, an age problem. We're just going to set this up. John is 23 years old. John's age is 3 years older than twice Mindy's age. Let M represent Mindy's age. What equation can be used to solve for Mindy's age? Alright, so we're going to start off with, let's say this. John is, based on that second sentence, John is 3 years older than twice Mindy's age. J equals 3 plus 2m, but they tell us what John's age is, 23. 3 more years than twice Mindy's age, and we're just setting this up. If we wanted to find Mindy's age, we could subtract 3, divide by 2. I think Mindy would be 10. Do that real quick here. Take away 3, and then divide by 2. Yeah, Mindy's would be 10, but they just wanted the equation. So notice how I set up the equation. J equals 3 plus 2m, and then we just went back and substituted in the 23 for J. Alright, thanks for watching. Hope this helped with solving equations.